So in this video we are going to look at another way of using algebraic identities. In this case I will use the expression a plus b plus c whole square, and I'll use it, for example, to square a 3-digit number. So let's say I have a number 546, right? And basically the question is, what is the square of this number? Yeah. And how do I use the algebraic identity to do the square? And I'm going to extend the square method that we had in order to do it. So the first thing I'm going to do is I'm going to rewrite this as ABC. So I'm going to write 100A, or maybe I'll use the same pen sort of, yeah, plus 10B plus C. Okay, so because I have a 3-digit number and this is 5 hundreds, 4 tens, 40 and 6, so I'm going to write it as 100A plus 10B plus C so that I can see what happens to it, right? So I want to square this expression, right? And so essentially I'm going to get a plus b plus c whole square is a square plus b square plus c square plus 2 times ab, 2 times bc, 2 times ac. This is what I get. So I'm going to do the same thing with using 100a, 10b and 1c. So the first thing I of course get is the square of each of them. So that is 4 digits, 4 zeros and a square, right? Plus so it will be left shifted by 2, that's multiplied by 100, b square plus c square, which will be within 2 digits, right? Because this is a digit. C is a digit, b is a digit, a is a digit. Okay, so this will be the first 3 terms, right? So the next terms will be plus so it's 100 times something, so I'm going to just say, okay, 2 times 2, I'm going to use, okay fine, I'll use a new color, double off, right? So 2 times so I have 100. Now if I do AB, I get a 0 from here, right? And then I get my AB. So when I multiply AB, it's sort of left shifted by 3 digits, yeah? Then I have plus, let's say I do AC. So AC will be again 2 times. Oh, okay. So I have 2 times 100, right, times A and C. Okay, so that's this one and that one, AC. Okay, and then of course I have the last term, which is 2 times 10BC. Okay, so why have I written it like this? So I have written it like this because I want to map this to the squares we used to do with 2 digits. So I want to do that with 3 digits, which is what I'm going to do next. So I have 5, I have 4, I have 6, and as always I'm basically going to give 2 digits to each of them. So a 6 square is of course just 36, 4 square is 16, and 5 square is what did I do? Sorry, 16, and 5 square is 25. Now why can I do this? I can do this because c square, right, is simply 2 digits. B square is multiplied by 100, so it's left shifted by 2. So that's why I can write 16 hundreds, right? And A square, which is my 25, it's 25, basically 2,50,000, that's what it is. So it's left shifted by 4 digits, so that's why I can just write it directly here. So that accounts for these 3 terms, right? This is here, this is here, and this is here directly. Okay, so they are done. So the next thing is basically now I need pairs. Okay, so when I do BC, which is 4 6 are, right? So that's 24. Now I know that it is double of that is what I want, so I should have written 2 times directly itself. Okay, so you do 4 times 6 and then you double it, which gives you 48, right? And as we used to do with squares, 8 will come here and 4 will come here. Why? Because you have 1 0 here. So that 0 is coming from the blue. I hope that's clear. Okay. So the next set of numbers, so this one is complete. This guy is basically this. So that was BC, the smallest digits. Okay, the next I'll do is AC because I want C is only a single digit. So it's a units place. So that's going to give me the number of tens, number of hundreds, and then number of thousands. So that's going to give me the 5 times 6. So 5 6 are, so I got 30. Okay, fine, 30. And then I have to double it, 2. That is 60. Okay, now where does 60 come? So as we said, that's 2 hundreds. So you see these 2 zeros? That's what I'm putting here, right? Okay, so now I'm doing AC. So I need to write 60. Okay, so I will just choose to write with this color because it looks similar. Okay, so I've got that. And then, so I have done this next term, which is AC. Okay, and then now I need to do the last term. So the last term is here, and so there's 1 0 because of that, and I have 2 more zeros. So it's this term, I'm doing this term, right? And so that's just AB. So AB is 5 times 4, which is 20, and I double that, and I get 40, right? So that's it, that's the last term. So I can write 40. Yeah. Well, the colors are more for these. Yeah. Anyway. And then basically I add it up. I get my 6. I get my 3 plus 8. It's 11. So I get 4 plus 10. That's 11. And then I get, yeah. So I get my 8. I get my, well, if I'm not really following color code. Okay. So that becomes a square of a 3-digit number. So this is almost following the same convention as what we were doing for the 2-digit squares. We've added a 3rd digit, and once we've added a 3rd digit, that square comes here. But also there are 3 terms. In the squaring it was only when I had just BC, for example, 2-digit number, I would have had just this 10 to BC, that would have been just this much. But now I also have AC and I also have AB. So the AC will be a number of hundreds and the AB will be number of thousands. So I'll just remark the zeros so that 10 is what's coming here, that 100 is what's coming here, and that 1000 is what's coming here. So I hope that's clear. So this gives a shortcut to be able to do a 3-digit square, and hopefully children are both able to see the pattern as well as see that it's a shortcut to be able to do what they need.